This is the first in a series of videos focusing on temperature. We will start our discussion by focusing on the question, what keeps the balloon inflated? And use related concepts to develop an understanding of temperature. Note that this depends on understanding our underlying model for the gas in the balloon. All the particles of a gas are far apart in constant motion, and there is a range of speeds. There is a well-established understanding of the distribution of speeds, and the distribution is different for each gas depending on the particle mass and the temperature of the gas. Note the distribution is asymmetric as there are a few particles moving at high speeds. About 5% of those shown here are high-speed particles. But the average speed of the air particles is the best way of thinking of temperature, and this average speed will increase as temperature increases. The pressure inside the balloon that keeps it inflated is due to moving air particles colliding with the inside of the balloon. There are also impacts of air particles outside of the balloon creating pressure. The pressure inside must be slightly greater than the pressure outside, since it also needs to counterbalance the elastic force, the stretchiness, exerted by the balloon itself. If we cool down the balloon by placing it in liquid nitrogen, we will lower the average speed of the air particles, and the balloon will no longer be nearly as inflated. As the gas in the balloon warms up, we can watch it expand and slowly return to room temperature. As the average speed of the air particles increases, the pressure inside increases and the number of collisions between air particles and the wall of the balloon increase. Keep in mind that there are always impacts between the balloon wall and air particles outside the balloon as well. Well, maybe not always. The balloon is placed inside the vacuum chamber. What will happen to the balloon if we pump the surrounding air out of the chamber? Please record your vote on a piece of paper and explain your method of answer determination. Your instructor will now stop the video. Let's actually watch the demonstration. When we first showed the balloon, we described that there was pressure on the inside and outside surfaces of the balloon created by the motion of gas particles. If we remove the air outside the balloon, only the pressure inside the balloon remains, and it quickly exceeds the elastic strength of the balloon. An inflated balloon wouldn't last long in space.